Yo, what's up, Sci fam? We're here in unit number 9, chemistry. And before we can dive into chemical reactions and understanding what truly chemistry means, we need to first kind of dig into just making sure that we're clear on different states of matter. So let's zoom in on the world. So we need to make sure that you're setting up your science notebook appropriately. So you can kind of get an idea of what we're going to include on this page. A states of matter title, we're going to define matter. We're going to show the 3 different states of matter in a scale of showing the molecules and their behavior. We're going to define temperature and heat. And so let's try to fit that on this page here. Let's dig in. Matter. Matter is the physical material of the universe. So all of the material in the universe could be considered matter. So let's look at an ice cube, because since it is a material here in our universe, we can consider it to be matter. So we have an ice cube. An ice cube is made out of water. Water is H2O. That is the chemical formula for water. So here we have our ice cube. And you can see it's even melting a little bit there on the bottom. So this here is a physical material. It's something you can touch. It's something that you can hold. And so we'll call this first thing our matter. Now, if we zoom in on the matter into this little point, we'll find one of these molecules here. Now, this molecule happens to be H2, because there's 2 H's, and an O, oxygen. And so this would be a water molecule. So these molecules make up the matter, okay? Or matter is made out of molecules. So those two are tied to each other. Like I was saying, these 2 blue things that look like the eyes of the alien, these are hydrogen atoms. Now, since they are specific elements, we call them atoms because it's just one of the specific elemental pieces. It's one hydrogen atom connected to an oxygen that's connected to another hydrogen atom. So this thing in the middle is our oxygen. You can see it's much larger than hydrogen. So again, these are atoms. Well, if we then look at this little framework that we made below the ice cube and our diagram, we can see that atoms make up molecules. Atoms make molecules, molecules make matter, and so on. Or we could say matter is made of molecules, molecules are made out of atoms. So a molecule is just a collection of atoms. So this is important because as we dig deeper, these are going to be common vocabulary terms. Whether we're talking about matter of the universe or molecules or atoms, it's important to know the difference. So these atoms, hydrogen and oxygen, make up a molecule of water. Molecules of water make up an ice cube, which is our example of matter. All right, so there is different states of matter. And so if you think about our ice cube would be an example of a solid state of matter. The matter in our example is water. So when water is solid, in chemistry we use just lowercase s in parentheses to symbolize a solid. And a solid has a definite shape. Like an ice cube, it has a very definite shape. It doesn't change or mold, and it has a very definite volume. Not like how loud it is, but volume in terms of how much is in the space. So if I were to show the molecules in an ice cube, I'm just going to draw some circles here to represent the water molecules. So each circle represents H2O. So I have several molecules that make up my ice cube. You can see they have a very definite shape, and they have a definite volume. Now, when we move on to a liquid in chemistry, liquid is symbolized by a lowercase letter L. I like to draw those in cursive so you can see that's an L, just not like a capital I or something. Liquids have a definite volume, but they don't have a specific shape. They actually take up the shape of their container. So if this box is my container, or better yet, you know what? Let's draw ourselves a bowl to collect our water. In that bowl, then, the water will take up the shape of the bowl because it's what we would call a liquid. So a liquid is still a bunch of those molecules all collected together. but it takes up the shape of the bowl or the container that it's in. And it has a definite volume. There's constantly, you can see the amount of water that's in there or the liquid. It's definite. It fits in the bowl, just like the ice cube when it's sitting there on the desk or the table. That's everything. With a gas, though, a gas is a bit different than a solid or a liquid, obviously, and solids are different than liquids. Liquids are different than gases. Gas is we use a lowercase g to symbolize a gas. A gas has no specific shape or volume. You can never really measure the volume of a gas unless you have a closed container. So if we were boiling the water that's in the liquid, then it's going to start to create steam, and it just like occupies a lot of space, and the amount of space changes depending on how long the boiling has happened and so on and so forth. And so if we just show the molecules in a gas, they're definitely way more spread out. And when they are spread out here, they're not just in space, but they're actually moving quite fast. And so we can draw some speed lines on these to show that there's a lot of motion happening here in a gas. And actually in a liquid, these molecules are actually vibrating quite a lot. They're moving around, and they're in what we would say they're in solution. So I'm going to draw some little lines here to show that they're vibrating. And in a solid, they're actually vibrating too, to be very specific, but it's just they're vibrating very, 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 very slowly, or they're not really in that much motion. Okay, well, if we then look at the amount of energy that's in these, you can see the solid, it's kind of like if you're shivering, you're not moving very much. And also solids are typically going to be colder. So if we use this kind of like framework down here on the bottom, we can say that a solid is going to be much colder than a gas. If we want to create a gas from a solid, all we have to do is heat up that solid, and it will go from being in the solid state to the liquid to the gas state. There are some exceptions, but we'll talk about that here in a little while. So I'm talking about temperatures here. I'm talking about heat. So what is the difference between the two? Well, temperature is basically just the average kinetic energy. Long ago, when we learned about physics, we learned about potential and kinetic energy. Well, kinetic energy is the energy of motion. If you recall, which I'm sure you do, kinetic energy means that things are in motion. So temperature is an average kinetic energy of matter. It's a measure of the average kinetic energy of matter. So if we take the temperature of a gas, there's a lot more motion energy in a gas than there is in a solid. So therefore a gas, if we measure the temperature of it, it will have a lot higher temperature, which I just noticed something that I messed up. If we have cold and heat, this could be just cold. A solid is cold and a gas is hot, not heat. Anyway. Okay, well, temperature is the average kinetic energy of matter. Heat is different. Heat actually describes the flow of energy. And it flows from hot to cold. So if there's something that feels cold, it's actually because when your hand touches it, that cold thing is pulling heat from you, and since the heat is leaving your hand, it feels cold. That's what happens when you touch metal. If you touch the metal leg of your chair, that's exactly what you're feeling and why it feels cold. So if heat is the flow of energy, temperature is how much the matter or the molecules are in motion. You can see that heat and temperature are different. So if we talk about heat, we're talking about this transfer of the kinetic energy from one place to another. So that's the main difference. And so if we heat up water, we're adding energy to water molecules. And so it will turn from an ice cube to liquid to a gas. But there's actually some interesting situations where things like a solid can go directly into a liquid, which is pretty normal when you add some heat. And we call that melting. So there's just some fun kind of terms that we use when we change states of matter. And so you can kind of squeeze these into the margin there or on the next page if you need to. But if it goes from a solid to a liquid, that's melting. Obviously, you guys know that. How about a liquid to a gas? That is vaporization. So if something is vaporized, it goes from being a liquid into a gas. If something jumps from liquid and then cools or heat is removed to it and it turns to a solid, you guys should all know that's like how you make popsicles. This we say it freezes. When something goes from a gas to a liquid, this is like the steam in your bathroom when you're taking a hot shower. All of a sudden there's liquid on the mirror and we call that condensation. Or you have a nice cool glass of ice water in the middle of summertime. All of a sudden water ends up on the outside of your glass even though you didn't add it there. That's because the gaseous water in the atmosphere attached and turned into liquid on your glass because it cooled down so much. If you go from a gas to a liquid, you have to cool down. That glass of ice water cooled it down and caused the gas to turn into a liquid. We call it condensation. And lastly, if you have a solid that turns into a gas, yeah, that's a big old jump. So think about snow turning into steam. That example is something that we call sublimation. So there you have it. There's some extra kind of extension vocabulary terms that are interesting nonetheless. So add those in if you can. But you know what? That's a wrap. Let's move on. Let's dig in even more. Let's look at these bonds. Let's look at changes, physical and chemical changes. I'll see you on the next vid, folks. Peace.